Hey guys, welcome back. Houston Math Prep here. In this video, we're going to take a look at the whole number divisibility properties. But let's start with answering the question, what is divisibility? Well, we see this notation B with a straight vertical line A. And the way that we read that is B divides A. Now, mathematically, what that means is for any whole numbers a and b, where b is not equal to 0, b divides a means there is a unique whole number q such that a equals b times q. Now, that may be quite a lot to take in, so let's kind of put it in words. B divides a means that the division problem a divided by b has a remainder of 0. Or one other way to say that is that a divided by b goes in evenly, or b goes into a evenly. So just some vocab that we're going to use in the next couple of properties. We're going to call b a divisor or factor of a. And we can call a multiple of b. So the divisor or factor is what goes in evenly, and a multiple is something that divides evenly by something else. Okay, now that we've got a working definition for divisibility, let's look at some of the properties of divisibility for whole numbers. So here's our first one. Mathematically, we say, for any whole numbers a and d, if d divides a and n is any whole number, then d divides n times a. Now again, let's keep putting these properties in words so that they're easier to understand. That says that if d is a factor of a, then d is a factor of any multiple of a. So if d goes evenly into a, then d goes into any multiple of a. Well, let's check out why is that true using our definition of divisibility. Well, we know that if d divides a, then a can be written as d times some number q. That's just our definition of divisibility. Well, if we multiply both sides of that by n, then we get na equals n times dq. Or if we just rearrange using our commutative property, we can write that as d times n times q. So that would mean that d divides d times nq, and of course then d divides na. So here's just kind of a little mini proof just using the definition of divisibility and some easy substitution to show why if d divides a, then d divides any multiple of a. Okay, let's check out our next property of whole number divisibility. Well, mathematically, we have this property for any whole numbers a, b, and d. If d divides a and d divides b, then d divides a plus b. If we put that into more normal words, we can say that if d is a factor of both a and b, or we could also say if d goes evenly into a and b, then d is a factor of, or d goes evenly into the sum of a and b. Just like the last one, let's look at why we can say that that's true. Well, if d divides a, then we can write a as d times some number q. And if d divides b, then we can write b as d times some other number p. Those are both just a rewriting for our definition of divisibility. If we change out a plus b for dq plus dp as above, right? A is dq, b is dp, then we can see that we can factor out our common factor of d, and a plus b can be written as d times q plus p. Well, then we can see that d divides d times q plus p, so therefore d divides a plus b. So if d divides two separate numbers a and b, then D divides their sum also. Our next property, said mathematically, is for any whole numbers A, B, and D, if D divides A, but D does not divide B, so that's what this little divides with a slash through it means, D does not divide B, then D does not divide A plus B. So in words, if D is a factor of A but not B, then D is not a factor of A and B. So why would that be the case? Well, if D divides A, then we can write A as D times Q. That's our definition of divisibility. But if D does not divide B, then that means the remainder when we divide B by D is not 0. So B would be written as D times P plus R, where this remainder R is not 0. So if we then substitute A plus B for dQ for A plus dP plus R for B, then we can take a common factor of D out of dQ plus dB, but we still have that remainder R. Then we can see that because there is this R, D does not divide this sum, so D does not divide A plus B. Our next property of divisibility has to do with subtraction, and that says that for any whole numbers A, B, and D, if D divides A and D divides B, and A is larger than B, then D divides A minus B. Now this A greater than or equal to B is only there because, remember, for whole number subtraction, that subtraction is only defined where A is bigger than B. So if we put that in words, that would be if D is a factor of both A and B, then D is a factor of their difference. So why is this the case? Well, this is going to look almost identical to the proof of why D divides A and D divides B means that D divides A plus B. So here we go. If D divides A, then A equals D times Q. That's our definition of divisibility. And if D divides B, then B can be written as D times P. Again, just our definition of divisibility. Then if we write A minus B as D times Q minus D times P, and we factor out that common factor of D, we have A minus B is D times Q minus P. Then we can see certainly that D divides D times Q minus P, so D divides A minus B. Okay, so our next property of divisibility is actually kind of a two-parter. For any whole numbers A, B, and D, if D divides A but not B, then D does not divide A minus B. It also works this opposite way, right? If D does not divide A, but it does divide B, then D does not divide A minus B. So basically, in words, if D is a factor of only A or B, but not both of them, then D is not a factor of the difference of A and B. To see why, this is going to be the same proof as why if D is only a factor of 1, it's not a factor of the sum. So here we're just going to show the case where D divides A but not B, but the proof would be the same for D doesn't divide A but does divide B. So if D divides A, then we can write A as D times Q. And if D does not divide B, remember, that means there's a non-zero remainder. So B is D times P plus R, where R is some non-zero number. So if we substitute A minus B equals dQ minus dP plus R, so just substituting for A and B, then we can distribute our negative here, and factor out our common factor of d to get d times q minus p minus r. Then, because we have this minus r remainder, we can see that d does not divide this difference, so d does not divide a minus b. Alright guys, well, that does it for this video on whole number divisibility properties. Until next time, we'll catch you in a future video.